Alright, diving back in. Change the wallpaper. I think this is absolutely hysterical. It's Mr. Albert Einstein, famous picture. What makes programmer? Problem solving skills with a Z. Nunchuck skills. That one speaks for itself. Research skills with an S. Caffeine addiction and passion for the win. All right. Bring Steam up. Close it. So, got rid of Notepad. Where am I getting these pictures? How am I arriving at these the great conclusions and the great images that we're putting up here on the desktop? It's pretty simple, really. I'm going to Google and I'm typing in programming pictures, and it's giving me a list. So if I wanted to demonstrate that, we're at Google. We hit forward. What did I type in? Typed in programming. Clicked on this little thing here, the tag link, if you will. And there you go. There's John McCarthy, passing judgment. There's a couple other things. We can go with a picture like this. I don't know. I want to say a couple of videos ago we had a picture like that. Something like this. I don't really like pictures like this because they make me think of I don't know, is some guy who maybe wrote a little code and now works on Madison Avenue. He's let's cash in on the idea that everyone's reading 1 and 0. Something like this. What is this? I'm completely confident what I'm about to say. There is not a single person in the entire planet Earth who can look at this and in 2 seconds know what this means, or even a minute. They have to get out, a calculator. Maybe they don't need a calculator, but they're definitely gonna, what they're gonna do is, they're probably gonna pull up Notepad, maybe a real, actual pen and paper, and they're gonna start, breaking out values and stuff. And plus, there's no context associated with it. I don't know. It rubs me the wrong way, but it's clearly not why we're here. Let's open up Python, break it out a little bit. We'll cover Einstein's head, problem solving skills, and I don't know. Well, now we'll move it over here. We'll leave Einstein in the picture. Einstein happens to be the name of my dog, or half his head anyway. Einstein happens to be the name of my dog. Why is he? Why did I name him Einstein? Big. I have a nice hobby for, or at least in some point in a previous life, I used to read a lot of physics books and general relativity and stuff like that. Big fan of Einstein, obviously. That's all I'm gonna say. So how much time did I just chew up there? It's just ridiculous. I don't know what to say. I have a real problem. 3 minutes. 12 minutes left. Python goofiness. What we're gonna dive into. So we're gonna do a couple things here in Python, just sort of finish up messing around and prove the point a little bit more that what do we mean when we say that Python's a fully mature programming language and we can do anything we want in it? Well, what we mean is that we can bring our computer to a crashing halt if we want to. We can just essentially we can write a program. I mean, is that what scientists and people, academics and whatnot mean? Like, oh well, such and such is a full-fledged programming language. What do they mean when they say that? Do they mean that any full-fledged programming language can bring a computer to its knees? Unequivocally, that is not what they mean. There are certain aspects of a programming language that, in the realm of computer science, you know, mean that we're going to categorize it this way or that way, or what's the style that you use when you use programming language X. That's part of what contributes to how that language is categorized and defined in an academic sense. So the statement that I just said about bringing a computer to its knees is a bit of a misnomer. Is it a bit of a misnomer? No, it is a misnomer. But for our general purposes here, we're just gonna screw around, goof around. I can already feel it. This is gonna turn it into 2 videos, but whatever. We're gonna have a little fun, and we're just gonna sort of demonstrate some programmatic concepts using Python. It's relatively easy to read. We can, it's somewhat pseudo English, if you will. Is it? That's what we're gonna say for now. So let's and again, similar to the last videos, just to stress one more time that we're gonna go over things here in the language of Python. I'm going to briefly maybe explain what they do and whatnot, but I'm certainly not going to pull up a Wikipedia page. Well, I mean, I will do that now, but when we're going over certain things, like a for loop is a control structure or logic. yeah, we'll just say it's a control structure that we're going to go over, or that I'm going to use in Python. We're not going to dive in and talk about how it's implemented under the hood or anything like that. Bits and bytes, certainly not. Anything you want to know about Python, you can certainly find starting from this page right here. From the most abstract thing that you can possibly think of, if you navigate through all these links and whatnot, you'll eventually get to a page where there's only probably 10 people on the planet Earth that understand what that page is trying to say, and all 10 people of those, or all 10 of those people, were probably involved in writing that page. Let's see if we can demonstrate that real quick. We're going to click on high level programming language. It's going to bring up a large thing. What are we going to go? We're going to go with natural language. All right, what is a natural language? Well, in the philosophy of language, it's something that has other things to do with other things. So let's click on what's a extremely sort of abstract, cognitively normal, neurotypical. Let's do that. That sounds totally ridiculous. See how small this article is? I mean, what is neurotypical? Well, it's a term, in the autistic community. That's unfortunate. Let's go back because we're gonna say something there that waggle dance. Oh, we're definitely clicking on that. What's a waggle dance? Well, there's a picture here, and there's some bees or some things, and it's a form of beekeeping and ornithology and things like that. Who the hell is gonna Google or gonna search Wikipedia for waggle dance? People who have probably consumed enough alcohol, or their own body weight in alcohol. That's who's gonna look for that. It's great that it exists, and not only does it exist, but it looks like a pretty in-depth article. So, we've demonstrated the point that jumping off here from Python, not only can you get into programming concepts that are so ridiculously abstract and obscure and niche or niche, as the case may be, that you can, it's as complicated as you want it to be. And it also, this will, link you to all sorts of features about the language. So anytime we're talking about something, or I'm doing something, demonstrating something here in Python, and I'm not going into great detail, and you're cursing me out, and oh fuck, I want them to go into detail. Well, you know what? I'm not going into detail, one, because I've already recorded 8 hours of video, and so there's that, and that all the information is at your fingertips in a much more concise, academic, and formal way than I could ever deliver it via screencast. So, let's see, how much time do we actually have left? That's what we got. It's just, I don't know. Again, there's a problem. So what are we gonna do? Python is a language, has a syntax. We've already gone over that a little bit. X equals 5. What is X? X is a variable, has value 5. We can mess with X. We could add 1 to X. We could use a different operator. What is Python returning in this respect? Is this the value of X? No, this is the value of X plus a constant of 1. Basic stuff we've gone over. We can introduce a new operator. We've sort of highlighted the equals here a little bit. Talked about how it's an operator. What is the what does the equal or assignment operator do? Well, it takes the value on the right. Whatever you could put an expression over here and string together arithmetic and things like that. Let's do that. We could do 5 plus 1 plus 1 plus 1. What are we going to get? The value of X is going to be 8. Type in X. We see the value is 8. So again, there's an operator here. What is that operator? It's the equal sign. We have an expression, if you will, over here on the right. It's going to reduce that expression to the simplest form, which is some result. It's going to take that result. It's going to stuff it in this variable. And then we could reassign that variable. What's X? X is 5. Well, now X is 6. What is X? X is 6. Now, in the previous examples we saw, there's a whole lot of black magic here going on as far as memory allocation. And we sort of were saying that there's a reason why that exists, because we want to increase productivity. That's exactly why it exists, and that's exactly why we're not going to sort of jump into that right now, because we're not using cheat engine, we're not looking for values, we're not manipulating things. We don't care about any of that. As a matter of fact, the fact that the memory manager exists and is doing black magic is really helping us keep this somewhat simple. So again, we're gonna open that up. So what are we gonna do? Well, let's open up Task Manager. All right, so we're about to do something here. Is something you should never do. We're going to be recording video, and we're just going to start eating up all the memory in our computer. Now, how are we going to do that? How are we even going to gauge that? Well, we're going to use the Windows Task Manager here. Let's see what's a better way to do this. Do it over here. So this is our active window. We can type crap in, and over here there's sort of a little visualization about what's the memory used for a computer, or for our computer. Is there any way that we can quantify that we do in fact have 16 gigs of memory? Well, you could go left, and then there's maybe 4 there, then maybe 6, then maybe 8. That's half, so you double it with 16. That's ridiculous. You can see down here in megabytes, what's the memory, physical memory of the machine? It is 16,000. In megabytes, it's about 16 gigs. In cached, there's some cache stuff, and there's some other interesting details. So when we write a program over here in Python and start ripping up the memory and chewing it up and doing all sorts of crazy things, this is just going to shoot up, because this program over here, we're not going to set any sort of hard limit on how fast it's going to run. This is going to execute as fast as the processor possibly can, and this processor is pretty fast, and so the amount of time it's going to take to go through one cycle, if you will, or iteration is the more technical term, of our little program is, I mean, this should just shoot up in less, I don't know, all abstract concepts, but let's say 20 seconds is what I'm going to ballpark. So, all right, how are we going to write this? How many lines do I think? Well, I sort of have it in my head. I have not tested this before. We're just flying by the seat of our pants, so if we make some mistakes, that's fine. How much time do we have left? It is time elapsed 700 seconds, 915. So we got about 200. What is that? About 3.5 minutes. So should be enough. So again, we're gonna write this program. We're gonna tell Python to execute it. We're not gonna give it any sort of exit condition or anything like that. It's just gonna run and run and run and run. And we have to. There's certain ways which I'm not gonna talk about, but there's a way that we can terminate this. Hopefully, if we cannot terminate this and this thing just goes absolutely out of control, then this video may completely fall apart. And I'm you know what, I will try my best to make the computer recover from that scenario if it happens, and I'm going to upload this anyway. So if the screen immediately goes black when we hit enter and this program is processed by Python, then that's why, and I think it'll be hysterical. So how are we going to start this? Well, we're going to use the control structure in Python. It's called for. Is that what we're going to do? Let me think about this. How can we make this thing allocate memory? We're going to use a list. Use a list data structure. We're not going to talk about what a list is. So I'm going to say that we're going to append some constant value onto that list, and that's it. And we're going to hit enter, and I don't know, I'm flying by the seat of my pants. Is this going to make total sense? Will Python complain? It might, but we're going to hit enter, and this thing's going to run, and let's see what we get. So I don't know if the video is still running, but we come over here, see the memory usage here steadily climbing. 2.64, back down, 2.7, 2.4, 2.6, 2.5. It's getting up there. It is steadily increasing, but not at a rate that I would have wanted it to. I want to increase this value even faster. So we're going to interrupt this program some way. We wait a second or two. This should drop down. Should drop back down. So not going to drop back down. I don't know, sort of screwing around, sort of oscillating. So let's see if we can force that to drop back down. There you go. We typed this statement. It did something in Python, and this memory immediately went back down to where it was before we started running this thing. We're getting kind of close, so we're going to stop this, come back, and with the full 15 minutes and no BS on my part, we're going to see if we can really get into some crazy stuff and make the resource usage just completely shoot up and get crazy.